the topic of this meeting today is data quality issues. So, as you know, a data analytics platform dealing with interval data from many different sources, could be automatic systems, could be manual inputs, could be automatic systems of many different sorts, could be meters on the side, so also affected by whatever happens in the location they are installed. Data quality is a big deal. Data quality is what ensures that not only you are running your analysis in a way that is meaningful to you, but also it is what makes the final user confident that what they are seeing is reliable. So with that in mind, the agenda for today is all dedicated, aimed at making sure that you can recognize and you can solve data quality issues. So we will start from figuring out what a data quality issue is and what types of data quality issues are you may come across. We'll dedicate some time to the detection and the diagnosis of these problems. So figuring out the additional information on those that allow us to narrow down the scope of the problem and identify a possible solution. Now, I put new solutions because there will be something new that I have to show you, but there are also solutions that have been around for a while. So I will also mention those. And finally, mitigation and prevention. So making sure that the impact of these data quality issues is reduced as much as possible. And whenever there is an option to do that, is also prevented. So we're trying to avoid that this is actually showing. The steps of a data quality process, so that are aimed at improving the quality of the data that you are looking at in your platform, are 4 and are very simple. So the detection of the issue, this is going to be the first part of our meeting. The evaluation, so figuring out the additional information that will guide us to the next step, which is the solution of the issue and the tools that we will be working with. And finally, the mitigation and prevention of issues. So this is kind of a cycle that is supposedly that we would like you to embed in your day-to-day procedures to ensure that the quality of data is not only that this is not only a reactive process, but also a proactive one. So making sure that things improve not only when an issue happens, but also when everything is okay. And this is going to be the part of it that we focus on the most in this presentation. That being said, what is a data quality issue? So data quality issue, of course, is whenever you have, whenever your platform is displaying the data in a way that doesn't match with the reality of what's happening in your building, on your process. And I identified 3 different categories. The first one is a data processing issue. So when data is good in the database, but looks bad. And I want to open a little parenthesis here. When I'm saying data is good, but looks bad, I'm referring to 2 different parts of the platform and the architecture. So, I mean, the data is good in the database, meaning we receive data that is correct. And this is something that you can check in the data monitors in your platform. And in case you're not familiar with it, I'm just gonna show you what this means. In the admin section of your platform, you're gonna have this monitor icon. And this you can use to query. I'm gonna pick a random data point to query the database and to see the raw data that we received from that specific data point in the date and time range that you selected. So this is an electricity data point. So we have a very wide database with a number of parameters that are active powers, reactive powers, apparent powers, currents, line to neutral voltage, energy consumption, and line to line voltage. So the data that you are visualizing on the platform comes from this information that is then mapped, that is then actually processed based on the mapping of the data point. So the information that you provide upon creating the data points. This could be as simple as the frequency of readings that the platform is supposed to expect, and then are displayed in the tools that you are using with the dashboard. So, for example, in the breakdown section of your portfolio analyst, the data that you are seeing here is coming from the information that we were looking at before. That is then processed based on what like the setup information that we provided to the platform upon creating the data point. An example based on what I showed you here is in here we don't have an energy consumption register. So we are not receiving energy consumption data. So in the mapping of the data point, we provided the information to calculate the energy consumption out of active power readings. This is something that we enable to make sure that also the meters that were enabled, that were not storing energy consumption information, but just sharing active power readings, they were able to still display energy consumption information on the platform. So going back to my presentation, data is good but looks bad means that the information in the data monitors is in line with what you would be expecting. So the data there is good, is correct, and it's just a matter of making sure that the information is properly visualized. I color-coded this in green because whenever we come across a data quality issue, this is what we are hoping for. We are hoping that this falls into this category, not only because it is easy to solve and you will have the tool to do it on your own, but also because it doesn't imply any, let's say, corruption in the data set. So we have all the information that we need in order to get to 100% solution of the problem. Second category is the incorrect data. So this is when we have spikes, zeros, and more. So when due to some information that is like out of scale, for example, or missing on our database, you are visualizing, you're experiencing issues in the data that is visualized on the platform. And finally, this is color-coded orange because it could be a little more difficult to solve and it could require a little more expertise. But normally, it only implies a very small data loss, which is exactly refers exactly to the portion of data set that is generating the problem. Of course, there is a red one, and the red one is missing data. So this is data gaps or data that was deleted by accident, data that was overridden by accident, or even installation issues. But we're going more in details on each of the categories right now, so I can expand a little bit on what this could look like. So detection and evaluation. I'm going to go through each of the categories, and I'm going to show you what an example of a typical problem like that looks like. The first one is the data processing issue. So what we normally see is, well, this is a common example. So this is an example of data that looks good in the database, in this case, a cumulative database, but was wrongfully mapped when creating the data points or at some point by mistake or for any reason. And the platform is interpreting cumulative data as interval data. I actually have the same example on the platform here, so I can show you how that looks like. And I have two versions. I have pretty much the same data set uploaded into two options. So I have a cumulative data point that is mapped as a cumulative data point. This is a random data set, so the numbers don't necessarily make sense. But if we were instead to map this data point as an interval data point, this is what you would see. So It is a constantly growing number. Basically, it's just the new total that is uploaded as the interval energy consumption. So this is the trend, the pattern of a data quality issue like that. You would spot this very easily because of what it looks like. But in general, so as this is a very simple one to spot, and it may not always be the case, the workflow to identify and to provide and to gather all the needed information would be, once you spot the issue in the breakdown, you need to check the data monitors, and if you see that the readings are in line with what you would be expecting, then it means that it could be a data processing issue. In line means that there is no data gaps, there are no readings that are completely out of scale, and so on and so forth. So what needs to be done here is to check that the data point configuration is correct, so that you mapped the information properly on the setup of the data point. And then you, similarly to what you have here, you would, in that case, it means checking that the data point is mapped as a cumulative data point. Just to refresh your memory, I'm going to use this this scenario of the simplest available option, just to show you where to look at. The only difference between the two data points would be that this has a reading type set as odometer or cumulative. The new nomenclature is odometer, which is easier to probably to understand, because effectively we are gathering information from a meter that is working as an odometer. And this is the wrong data point. So that is marked as trip. So it's a trip meter. It's working exactly as a trip meter. And if we were to look at the data monitors, we would look at it, we would be looking exactly at the same data set. So it's just a matter of configuration. What this means is that in order to solve this problem, what we will need to do is just to change the information that is wrongful here, save, and then run what we call a reprocessing job. So reprocessing means that the platform will pick up information from here and will apply them to the data in the database, basically processing all the data through the set of information that it can gather from here. And once it does that, it will recalculate all the single intervals, and it will show the results that we would be expecting, that are in line with what you can see with this with the other data point. An incorrect data issue is instead, is still spotted in the breakdown or also through the alerts. So if you have an alert, a notification system that is attached to the specific data point, then you would probably receive a notification if you get a spike like this one. The peculiar thing with this is that you check the data monitors and you don't find readings in line with the expectation, but just in a very small part of it, most likely. So there is a random reading, a zero reading, a leap in the in cumulative readings. The data set is inconsistent, meaning that it may have some again, something like these leaps, or a reset of the counter. Sometimes it happens with odometers, or there might be negative powers. Negative powers usually are something that we associate to issues with the installations. If you were to install a CT with the wrong orientation, either on the meter or on the circuit, then some meters would interpret that similar, as if it was energy production. So it would see this flow of energy going the other way around with respect of the other CTs, if it's a three-phase meters, or the other channels, if it's a single phase meter. And then at that point, it depends on the manufacturer, what's the behavior. Like, I don't think that there is a right or wrong, meaning that if you have a cumulative counter and you are counting energies, and you are to send energy information that is aggregated, I don't think that there is a right solution when it comes to what behavior to adopt. So some could say that it makes sense to provide the net energy. Some would say only the positive energy, so the energy consumption, or only the negative, so energy production. In my experience, it's very common the second behavior, so to send positive, meaning energy consumption. But again, there is no right or wrong. So for this specific reason, we implemented the solution that you like. Also, because of this, actually, we implemented that solution that I showed you before, where a meter can only send that only sends energy. Active power readings can have energies calculated through the active powers, and we can set a filter in the active power readings so as to virtually flip the CT, basically. Basically applying an absolute value to those readings and turning negative power readings into positive ones, so that then the calculation of energies through power readings is accurate. This would still introduce some approximation, because of course, as you can imagine, it's not the actual calculation of energy, but it's more a calculation based on other parameters, so there might be some little discrepancies. But this is a good enough situation to ensure that you're not losing any data while you may be working on the fix. Like maybe you don't live close by, you cannot send people right away, and you still want to have a consistent data set until you manage to find a solution. The good thing is that this is also retroactive, so it could be a very good quick patch to an existing issue. Finally, missing data. So in this case, you can spot this issue using any of the tools, because this means that this issue is normally very easy to spot, because it is a pretty big disruption in terms of what the data looks like, if any, because this is actually just an example, but it's a common situation of missing data. You can also use, in this case, alerts and webhooks that are dedicated to that. So we have some tools that are dedicated to preventing that a data gap goes unnoticed. So when we are not receiving any data for a configurable amount of time, so you can set 30 minutes, 12 hours, 6 days, really, you have plenty of options, then you get a notification. Once you get the notification, first thing that I would always recommend is to check readings on the data monitor. And in this case, you would find that they are missing or severely corrupted. When I say severely corrupted, I mean that maybe there was an installation issue that, differently from the previous, which was a very simple one, a common problem that would fall in this category is when readings like the CTs are installed on a channel, like on one phase of a channel, but on a different voltage reference. So the energy consumption and actually all the parameters are calculated using data that are coming from two different places. So it's not really reliable data, accurate data at all, but rather some readings that don't really make much sense. Or it could be that by mistake you uploaded data on the wrong data point and the database is looking bad, data deletions and so on. So this would be the most dangerous issue, because, for example, an unwanted deletion of data means that the data is gone. There is no way to recover that information. And the same happens, of course, when you override readings from another system. So what are the solutions that we can put into action. So up to now, most of the options that you had when it came to a reactive solution involved reaching out to the Warix or SmartAnalytics support team to have them look at the data. Hopefully, you can provide them with some directions now that you have some more understanding of what each problem looks like in the different sides of the platform. But now we want you to be more autonomous, and also we want, because not only because it helps us deliver a better service, but also it helps you delivering a better service and a quicker fix to your own projects and your own customers. So we are proud to provide you with two new solutions for this, the first of which being what we call the data actions. So this is once again a reactive solution that allows you to do something that was impossible for you to do up to now for, let's call it security by design reasons. And that is to delete data, to reprocess data, and to operate in bulk to apply modifications on the updated mapping of data points onto a number of channels. So I would say this is the go-to tool for a clean database, and I'm going to show you how that works using some actual examples. So the data actions tool is found in the admin section. So this is not something that any user will have access to, but only the ones that you chose to elect as admins for your own projects. It is going to be in this very attractive bin icon here, and it's split into two different parts. So one that is called bulk action and another that is called the editor. So we're going to start from the bulk actions one, and I'm going to show you, I'm going to refer to the existing examples that I've shown you before. So referring to the issue with data points that were wrongfully mapped, where I have a cumulative data set and I set it as an interval data set. Well, if I were to just go to the admin section and change as I mentioned before, if I only were to change the mapping and save, well, this would apply to the data point, but only on new readings coming in. So you will end up having in this case, a super high consumption until March 2020, and then you're going to have a drop in the energy consumption, which actually is pretty true to life, considering that March 2020 was the pandemic start. So, well, not in this case. In this case, it's just a data quality issue. So what you would need to do in that case would be to go to the admin, change all the mapping as needed, and then come here and choose, select the data point that you would like to implement some changes to. So you can as well select the whole site and let the platform list all the data points that are inside that entity. The one that we would like to fix is this one. So I conveniently mapped it as cumulative data set interval mapping, even though now it should be odometer trip, but that's still pretty intuitive to me. What I need to do is just to select the start and ending date for a reprocessing job. In this case, it would be from September 2019 to March 2020. And then I could reprocess the data. So reprocessing the data would basically take all the readings in the database, rerun them through the mapping to figure out how to read the information and how to display the information. And differently from the previous, the cumulative or odometer mapping would tell the platform, okay, calculate the interval values as the difference between two consecutive energy consumption records in two consecutive streams of data. And doing so, it will basically fix the issue, thanks to the fact that we don't really have any problem in the data set itself. So the data set itself is good enough to go. What else I can do with this is I could delete the data. So in some cases, you have a backup of the data. In this regardless of the type of data quality issue. So it may be just as convenient to delete readings and to restart from scratch. One thing to make sure is to not to take this lightly, because this is the whole reason why we didn't open this to everybody, was to prevent that some unwanted deletions happen, because there is no turning back. So once the data is gone, it's not going to be possible for us to retrieve it. It's basically something. Basically, you clean the trash bin, and there's no way for us to go in there and pick things up. The second category, when there is a data quality issue that has to do with some wrong readings, could look like something like this. I hope I didn't fix this already. So this is a spike happening around 10 a.m. on the 19th of January. And we're going to look at what it looks like in the data monitors. Hopeful that I didn't fix this already without reprocessing, but let's give it a try. So this was in 2020. So I'm querying the database for the energy, all the readings happening on that specific time, on that specific day. And we should see something that looks odd in there. So it was around 10 a.m. So yes, there it is. So for some reason, the meter sent this 0.01 reading on this cumulative data point. So this is actually more common than one would think of. I was impressed by how many of these issues may happen because of any reason, really. And what the platform is doing here is, this is a cumulative data point. So the interval is calculated, the energy consumption in the interval is calculated as the difference between consecutive readings. In this case, 0.1, if I read this right. I don't have my glasses on. In this case, 0.2. In this case, 18,013, like 394.1, more or less, which is exactly what you can see here. So the platform is doing the right thing, actually. Is working with the data it has. So what we want to do here, and what we can do now using this tool, well, reprocessing wouldn't do much, because the platform, as I said, is doing exactly what is expected to. But through this editor here, what we can do is I can pick up this data point. I can go all the way to the 19th of January, 2020. I should put readings in a more recent day. But anyway, so what you're seeing here is the same. The same view. So this is the whole database. I can move this so that it's closer to the timestamp, and it's easier to read. This mouse. So there you go. So in here, well, this is, as you can see, is something that I can adjust in terms of the position of the columns, but it's pretty much the same. It's the database. And what you have here is the list of all the readings that we had on that day. So by scrolling, it should be very easy to find the one that is corrupted, and there it is. So this tool allows you to do two different things. Well, actually three. The first one is you can delete the reading. So you can basically get rid of just that one reading, commit, and then this time slot would be completely deleted. Alternatives are, let me undo the deletion. I can double click here and I can type the reading that I want. So 18,393.9. So let's go, actually they want a point here. So 0.9. So this would make it so I don't have any, well, actually the two options that I've shown you would mean exactly the same thing. So in one case, I manually provided an average reading. On the other, the platform would basically just calculate the difference between the two consecutive intervals. In this case, 94.1 minus 93.7, so 0.4, and it would just allocate it evenly throughout the missing interval. So it would have done pretty much the same that I did here. The third thing you can do is you can add a new row. So you can introduce the whole stream of data that would fix the problem. This is very useful in the event of actual counter resets. So if a meter reaches a certain number and then resets in order to restart from scratch, this would generate some corrupted readings. It would be difficult for the platform to understand what's going on. So you can introduce a null reading that tells the platform, look, from now on, you skip an interval because it wouldn't make sense. Like you have a 1 minus 32 billions, and it would effectively not make any sense. And then it would start calculating the energy consumption or any other metric from the next interval on. So this is also something that could be very useful to you. Once you update or delete or anything and commit the change, the platform will issue automatically a reprocessing job that is only happening on that specific day, and that will apply the changes that you implemented onto the data set and onto the data that you are displaying on the platform. And you will keep also this very convenient history of the energy consumption, like of the readings that were deleted, updated, reprocessed, and so on. So this could be very handy for you in case something is not going as you would expect, and because it allows you to better understand what was the workflow to get to a solution of the problem. So it didn't apply any changes. This is still looking odd, but now you have a way to fix that. So this tool is not available by default on your platform, meaning that it is available by request. The reason for this is that we normally, so in order to avoid that this is a tool that is used, let's say, lightly, what we normally do is we provide it for free, but we, like, just upon jumping on a training meeting that will show in detail what you need to do, what you can do with the tool. Now, if this is something of interest for you, we can provide that, because of course you now had some sort of training, but that still allows you to, like, you're still entitled to jump on a meeting with me, so you wish, just to have another look, maybe look at some actual cases, and we can check it out together. And that way, we want to make sure that this is incorporated in your workflow in a way that you have confidence upon, and that you trust can be an improvement to your workflow and not another potential issue in terms of the data quality. So this is the data action. I hope this is exciting news. If that wasn't the case, I have another new thing to show you, which is the data doctor. So the data doctor is instead a proactive solution. So in this case, it's something in between a mitigation strategy and a way for you to have a little better, better information on your platform. What this does is it rebuilds the missing data. I know it sounds odd, but I'm gonna go in detail on how that works and how that looks like, and ensures that the data that you're looking at is more accurate, and it also looks better, which is not negligible if you ask me. So to better understand how that looks like, I manually created an example like this. It's not very easy to show you on the platform because it's more like a configuration thing. So this is hopefully clearer than it would be by showing it on the platform. So what I did here is I picked up a data set, an actual data set from the platform, and this is what it looks like. So it is a complete data set. And basically, the idea here is to reproduce exactly the workflow that the platform would go through in fixing a data quality problem like this. So actual data set, I simulated a data gap. So I basically deleted a bunch of readings, and this would be what the data set looks like if nothing happens. So if we were not to apply any mitigation strategy, any solution, any re-uploads, and so on and so forth. What the platform currently does is this. So if this is a cumulative data set, similar to what I said before, what it would do would be to take this reading at 420-ish minus the reading at 730, more or less. The cumulated energy consumption happening during the gap is evenly allocated, showing something like this. Then, of course, it's going to be connected and everything. This is an Excel spreadsheet, basically. But the logic is as follows. Now, the big plus with this approach is that this is daily readings. If we were to zoom out and look at the daily total on a monthly time frame, you wouldn't notice any error. So this choice is aimed at making sure that the total energy consumption is accurate, is still a metric that you can trust. So this is good enough, but if you were a user of the building or somebody that just looks at the data, you would clearly understand that something is off. And in some cases, when there are like money implications or like we are using this for tenant building and so on, this could be a red flag. So it could jeopardize the whole project. So instead of proceeding like this, we chose to think of an alternative. So we tried to see what Sentinel was predicting as for the, in this case, active power usage. As you know, energy consumption. As you know, Sentinel can work with both, but as you know, we can pass from one to the other. And this would have been the energy consumption simulated by Sentinel. Now, thanks to the fact that we also have the cumulated energy consumption happening on that interval, what we can do is to shift this curve. So basically to apply a conversion factor to each reading that is based on what we want this curve to look like. And this would be exactly what Sentinel would, like what the data doctor would have done in this situation. Now we compare it to the actual situation. So the very first graph that I've shown you, and you see it's not 100% correct. But a big advantage is that, well, on one hand, the energy consumption, the total energy consumption is still accurate. On the other hand, is that if you were to look at this trend, well, you may wonder why these dips happen. But in general, you would feel confident that the energy consumption was all captured, so that the data that you're looking at is reliable, and it doesn't look like it wouldn't raise a red flag. So that is the goal of Data Doctor. Data Doctor is native to only operate with cumulative data, and the reason is very clear. So the fact that we can rebuild a data set keeping the actual total energy consumption information intact, so without affecting that. We chose to also open it to the so-called trip meter, so the interval readings. And I was skeptical on this, to be honest, at first. But the idea here is that with the cumulative data, in the cumulative data situation, so on one end, we are printing data that is like a simulation. There is some sort of guesswork that is, of course, informed guesswork based on the Sentinel algorithm, but still, the alternative would be still protecting the total energy consumption. In the other scenario, our only option is to display zeros. So of course, the data doctor will be an optional behavior that you can choose to incorporate to a specific channel or not. But there is also the option now to make it happen for interval data points. In the case of interval data points, we wouldn't have been able to do the shift, but the alternative wouldn't be a flat line that captures that. It would be just a bunch of zeros. So it is a matter for you to pick what's the best option, also depending on, of course, on the specific channel. So there are some more predictable appliances out there for which the Sentinel model is very accurate. There are others that are much more unpredictable, for which Sentinel is doing its thing, but there is a wider range. So the room for errors is higher in that situation. Now, some frequently asked questions also coming from our previous experiences with the beta version of Data Doctor. So first thing, how to enable it. We can enable it on all the data points for you. We can enable it for all the new data points that you have. And you can still keep the ability to enable or disable it for the specific data point. If I still have an admin tab open here, I can show you how that looks like. Again, same data point. So the cumulative one here, I can enable this Sentinel-based backfilling. So what this means is that I click this and I save. From this point on, whenever there is a data gap, meaning that we have a last reading, a gap, and a first reading after the gap, then the platform will pick up these two information and will rebuild the graph for energy consumption happening inside. When and how it will jump into action.
Sorry to interrupt, but we had a question in the chat. I don't know if it makes sense to answer here or if you're going to cover it, but Scott asked if we could use real data for solar versus energy usage. And Scott, if you want to come on camera or on your mic to clarify, you're welcome to.
So yeah, I'm sorry I missed that because
It just happened. Don't worry.
Okay. Where is the chat?
On the right, if you click discussion.
Yeah. For some reason, they are using the same icon in two different parts for two different things. Real data for our solar versus energy usage. In my opinion, with solar, Sentinel would be very, very good, actually, because it is a much more predictable behavior than it is for other channels. And also imagine having a 24 hours long data gap. With the previous behavior, best thing you can do is a flat line, but flat line that would show, I don't know, some 10 kilowatt hours production at 1 a.m. in the morning, and same for the rest of the day. And this is definitely not what you would expect from your PV installation. So, of course, this would have consequences of messing up the calculation of the cost because related to energy consumption, because of time of use tariffs and so on. So definitely, this is something that you can do. It is a little more common in my experience that the solar inverters or metering equipment in general are sending interval data. So we always suggest double checking on the information that is there, because the risk here is that with interval data in particular, the platform would print your average day, basically. So the range of expectation depends on basically how cloudy it was in the window of in the time frame, the time that the platform is using as for the calculation of those Sentinel readings. But the beauty of this, and this attaches with the other, with the next point that I have here, is that you will be able to keep visibility on the simulated data, and this will be done through these like highlights that you can print. So these are effectively remarks. I don't know if you are familiar with remarks. So a remark is something that you can overlay to the platform. It is a sort of note, and it is actually a note with a timestamp. So I can write test here and save the remark, and the remark is going to highlight this part of the graph and telling me some sort of information. Now, this is something that done as I did is more interesting for sharing information internally with the team. So I could tag somebody here and ask them to check what happened here. In the event of the backfill data using the data doctor, the platform would automatically highlight the areas that were rebuilt by the data doctor, and the remarks would show up in the list at the bottom of the page. They will only be visible if you overlay, and only visible on the graph. I mean, only if you click on the overlay, and they are only active for admin users. So only users that have admin permissions, meaning that the average user wouldn't have visibility on the fact that the data set has been rebuilt by the Sentinel algorithm. So this would be only for you. And you can have an aggregated view of this by looking at the notes, which is, yes, here. So this is the list of all the notes and remarks that are available in any of the data points in my availability. Of course, this is a demo platform, so there's a lot of stuff that don't really make a lot of sense. But you can see here that there are some that say data gap period. These are also automatic, and these are already active for you. So whenever there is a data gap, at the moment, what the platform is doing is just highlighting that, because it may be difficult for you to spot that, in particular if it's a very narrow one, like a 15-minute data gap. Now you're also gonna have, if you enable the data doctor, a similar logic on the rebuild data sets. So this is going to help a lot in figuring out that something happened, and then validate that the work of the data doctor has been successful, good enough. And again, in particular with trip meters, it may make sense to double check and validate. But of course, keep in mind that you can choose, the option is there, but it's not something that you need to enable. So you can you can select the channels that you want that to happen on. So if you were not to feel confident in having the platform rebuild interval data, for example, then you can choose to disable the rebuilding of data only for interval data points, for example. Final strategy, don't forget the API, because the API has been there for a while. It's a bit of a, let's say, a pro tool, meaning that it requires some knowledge from the IT point of view, but there is a very good knowledge base that is available to you at developers.warex.com. In here, you have two different endpoints of our API that are very well documented. One that is the data push API, so when you need to upload data, which could be, of course, a way of solving issues. And another that is the dashboard management API, which allows you, for example, to query the data, to query the consumption from specific data points, and a number of other tasks that you can perform, and that can, if you have like your IT department, or if you have the knowledge that I wish I had, but unfortunately I don't, then you would be able to be much more advanced in manipulating your data than just through the user interface. Although, to be honest, the data actions tool has been something that I had the privilege of being a beta user for. So doing support, I can tell you how life was before and after the implementation of a solution like that. And I can tell you it makes a difference, because operating in bulk, or the ability to just change a reading in the database instead of deleting and re-uploading, like all those things, once you master the way it works, they are going to make a huge difference in the event that you were to deal with issues like that. So the hope is always not to have to deal with this type of problems, because as things like in the business as usual, you would expect these issues not to happen, but we know very well that they may happen, so it's good to be protected from those. So re-uploading data is the final, is the last resource. So now you can delete the data, which is something you couldn't do before autonomously using the data actions tool. And then you can use the embedded data uploader, or right, if I click here, it's going to change the slide. The embedded data uploader, you can upload data via FTP or SFTP. HTTPS pushes via API, or the MQTT option as well. So now I captured that there is a question. The true advantage for a state university to use this. Well, it depends. Honestly, I don't think that there is a specific persona or use case that would benefit from this more than others. It actually depends on how confident you are that the data is going to look and it's going to be accurate. This like data issues may happen for a number of reasons that doesn't necessarily come to a faulty meter or something like that. When running analysis, you may want to upload data that is instrumental to the analysis. So, for example, the drivers of consumption and cost, like occupancy, or like weather information, and so on. Bye, Jessica. So you would be introducing different ways of uploading data. You would introduce manual readings, or you might have different systems that are contributing to the same database. So this is more of a protection from problems that you may have in your day-to-day activities, which are honestly very difficult to anticipate, rather than a tool that would simplify your analysis. It's basically something that would make sure that you have all the needed information for your analysis. So I don't think that there is something specific in terms of advantages for your own sector. It is more of a, let's say, a horizontal measure to ensure that there is an improvement overall in the quality of data. I think Daniela.
Scott, are you guys using? I don't think you're using chargebacks, right? For anything. Ooh, you're muted. Camera's off. I can't see if you're nodding or not. But Lorenzo, is it accurate? Correct me if I'm wrong. But is it accurate to say that that's the integration between SmartAnalytics and utility management? If people are using chargebacks, it really helps with that because it's feeding that data directly into utility management.
Yeah, no, that is correct. So whenever data is then utilized across platforms, then you're going to have you're going to benefit from that. And in particular with chargebacks, there are like if you were to look at something like this in your data, and the billing is based on this, Yeah, this would raise some eyebrows, because it's like there might be now in this specific situation, it's something happening in the middle of the day, is just a few hours, but that's not always the case. Like there might be some occasions where it's a different, like it, and the issue is happening across multiple hours, and you have time of use tariffs, so there are cost implications, although it may not be huge. And yeah, this is basically a way to reinforce the trust of people that are built based on this, and also, if even if it is an internal process, it would make the whole thing a little more robust, because it's not really the size of the issue or how big the discrepancy between the simulated scenario versus the actual one that is a big deal, but rather how people perceive this as a tool that is sending random readings versus something that is actually reporting the actual figures. So that would be my my point of view if I were in your shoes. I'm sure there are like this is one of those improvements that affect the platform as a whole. So,
Danielle, can I ask a question for Lorenzo and you?
Of course.
So here at our university, what we do, our energy cap is what we get our budget off of. That's why I was asking about solar versus energy. We have to be able to calculate both what usage and what we save. So for us here at the university, we're the first ones really doing this. So it's new to South Dakota. So I need to be able to pull out that report out of Energy Cap and be able to use the real life data. So that's why I'm very interested in this.
mm-hmm. Yeah, no, I think that makes perfect sense. And yeah, having, of course, all that I've shown you today is not an alternative to how things are done at the moment. So this is just new tools that allow you to have something better, more automated, and so on. You can still rely on our help when it comes to assessing and addressing the data quality issues that you may come across.
And it all requires that we have meters on everything, right?
Well, not necessarily. I mean, you may have just one, and you may want to have a good platform for that. But yeah, in general, it depends on on your goals and on what you're monitoring. So
yeah, and the other. Go ahead, Scott.
No, I actually put meters on all our solar and all our meters on electric. So I have meters all over the place here.
Perfect.
Amazing. You're ahead of the game. Because I was going to say the other thing that we do is we integrate directly with a lot of utility providers. And that helps in that we can use their meters to get this data. So you don't necessarily have to install hardware. So that's also an option. But hearing that you already have yours, you're, like I said, ahead of the game.
Yeah. So I'm mindful that our time is over. If you have just, I think I only had another slide, and it's mitigation and prevention. But if you have any questions, I don't mind sticking around a little longer for those.
Will this work for Carbon Hub?
Say that again. Sorry.
Will this work for Carbon Hub?
The tools that I'm showing. Once you bring communication, the platforms, and you're using the data across them, then fixing the data in here would have repercussions also on Carbon Hub. So that's that ideally, you're gonna have some clean data on all the platform, and this tool should help you get there. So I'm gonna go ahead just for the sake of the recording. If you need to drop off, just feel free to go. I still need to finish my job here. The mitigation strategies. So mitigation, well, enable the data doctor. Enabling the data doctor would make sure that even if you had an issue, a data gap, a problem with data quality in that sense, then this wouldn't have the impact that you may expect as of now. So you wouldn't be the one to spot it, or you wouldn't risk that somebody else spots it for you. It would be only visible once the problem is already solved. I would recommend choosing cumulative data. This is oftentimes this is not an option, meaning that the meter will do what the meter does. But if you have the chance, choosing cumulative data would help a lot in ensuring that the quality of the information that you're showing to your users is intact. CDPD factors. So these are transformation factors. These are ways that we have to address these are a tool basically that we use and that we will use with you to ensure that some issues, in particular with installations, are dealt with. Transformation factors, in a nutshell, are something that we developed to make sure that you could have readings in the platform for higher tensions. So if you are at the secondary side of a transformer, where you are able to monitor with a normal electricity meter low tension loads, and you want to have visibility on the higher tension ones, so medium tension or even higher than that, this is where the transformation factors come to play. So they allow you to use a lower cost meter with, of course, lower protection from high voltages for the monitoring of higher loads. And basically they would simulate and revert in a way the behavior of the transformer itself. Now, this can also be used to mitigate some issues. So if there were issues with just a narrow part of the data set, because of installation issues, we could apply a conversion factor selectively only on some readings and try to see if that is a good way of fixing the problem. But this is more something that we implement once we are asked to respond to a data quality issue. As for prevention, set up alerts. Alerts will help a lot, in particular with data with offline meters, or whenever you want to make sure that, like Sentinel alerts, for example, to ensure that you don't have unexpected behaviors for your channels. You can investigate the option to enable webhooks. Webhooks can be found on the very last tool of your admin section, and they are data gap or Sentinel trends webhook. So basically what they would do is to generate a post message like this that they would send to a URL of your choice. And this can enable a cascade effect of, for example, there is data gap, well, download the data from the system that is feeding data to the platform. So these are all options that you have to generate an input that can then lead to a mitigation strategy of your own. And then meter rollovers. Meter rollovers is also something that is fairly new. It is a setting that you can apply to a cumulative data point this is a cumulative data point. So you can basically, so there are some meters that, as I was saying before, they reset the counter when they reach a certain amount. So you wanna, in some cases, this makes it very frustrating because it happens very often. So whenever there is a very high energy consumption in particular, it's very easy to reach that point where it then resets, and you would risk to have a very frequent event that could be annoying. So through this tool, you can configure the maximum meter value and a rollover percentage that allows you to basically tell the platform, okay, we are resetting the value. So just keep going with with the business as usual, basically, whenever you come across this. So we are instructing the platform to expect a reset at that point so as to minimize the effect that it has on the data itself. This is already available, it doesn't need any activation, and it's something that you will only see when the reading type is set as odometer or cumulative. And that's it. So with just 10 minutes delay, I managed to complete the whole presentation. I hope it was interesting. I repeat just one last detail, which is that in order to enable the data action or the data doctor or both, you just need to reach out to us, and we will do it for you. So if that's interesting for you, I can enable it right away, and still keeping the offer of jumping on a meeting, a quick one-to-one meeting to show you around, or even, I mean, it can be open to the rest of your team and any other users that you would expect to have access to the feature and work on data quality. So we can look at some specific cases, address some examples, and really start building the confidence that you may need in order to operate these tools.
Okay. Yeah, I'm definitely interested in the data doctor.
Okay.
So if you can activate that for me, that
sure.
would be
Okay.
great.
I'm going to send you an email so that I can capture the specific requirement. As I told you before, it can be set to operate in different ways. So to only operate on new data points, operate on all the ones that you have, maybe you want to start in one specific way. So I'm going to send you an email, and then we take it from there.
Yeah, sounds good.
Perfect.
Okay, good.
I thank you for your attention and for sticking around 15 minutes extra. And yeah, I'll reach out as soon as possible, and I wish you a great rest of the day.
Yeah, same to you. Bye-bye.
Bye-bye.